Okay, so for our second proof, we have here for the parallelogram, each diagonal of a parallelogram divides the figure into two congruent triangles. So as you can see here, we have here a parallelogram FEME and FEMN. Okay, so it's been divided into by two diagonals, and therefore it created two congruent triangles at both triangles. So we want to prove that that's true. So triangle FEN must be congruent. I want to prove the triangle FEN is congruent to triangle ENM, and triangle NFE is congruent to triangle EMN. So we're going to try to use the ASA, or the angle side angle triangle congruence postulate in order to prove this problem. Okay, so we have here our proof. Okay, so there are two types of proof that we've already discussed in our previous lessons during the first quarter. So there's the paragraph proof and there's the two-column proof. But we've been using the two-column proof extensively a while ago and in our previous lessons for module 1 and module 2. So, and also in the previous lessons in our first quarter modules. So here is a example of a paragraph proof. So given FEMN is a parallelogram with diagonals EN and FM, it must be proven that the triangle FEN is congruent to triangle ENM and triangle NFE is congruent to triangle EMN. So by definition of a parallelogram, it can be said that FN, line segment FN, is parallel to EM, and line segment FE is parallel to NM because they're parallelograms and they have two pairs of parallel sides. This implies that the alternate interior and corresponding angles cut by the transversals or the diagonals that we have there for our parallel lines are congruent. Hence, we have angle FEN is congruent to angle NEM, and angle FNE is, if you look closely, those angles here, the alternate interior angles are congruent. FNE and NEM are congruent, and angle EFM and angle NMF are congruent, and angle FMN and angle MFE are congruent. So we may have forgotten a specific theorem here in order to make it an ASA theorem. Okay, so we can insert here also using, okay, so if you look closely at the diagonals, we have here diagonals NE and FM. Okay, using the reflexive property of congruence, we can say that, okay, so we can say that NE is congruent to NE and FM is congruent to FNM. Okay, NE is congruent to NE and FM is congruent to FM. So let's type that. Okay, so let's make that. Okay, we can say that NE is wait, let's make it black first. Okay, so we can't see it. NE is congruent to NE, congruent to NE, and FM is congruent to FM. So we can add this statement, okay, in order for our triangle congruence postulate to be justified as a proof for this theorem or this problem that we have. So using the ASA triangle congruence postulate, we can therefore conclude that triangle FEN and triangle ENM are congruent, and triangles NFE and EMN are congruent, QED, or quad erat demonstrandum. Okay, so that's the proof that we have for our triangles. So how did it become an ASA proof? Okay, so we have here the angle EFN and angle FNE. Okay, so they're congruent with the corresponding angles on the triangle NME. And also we have here the sides. Okay, so the side measurements or the diagonals themselves, using the reflexive property of equality, we can say that they are equal to each other, and therefore through the ASA or the angle side angle triangle congruence postulate, those two pairs of triangles are said to be congruent. Okay, so now for our third proof, we have here proof number 3. We want to prove that the diagonals of a parallelogram bisect each other, or that CL for this figure, we have here CL is congruent to LP. Okay, it's congruent to LP, and we have here AL is congruent to this line segment LS. Okay. So we have here parallelogram CATS or CAPS with diagonals CP and AS. We want to prove again that line segment CL is congruent to LP and line segment AL is congruent to LS. So our main plan here, guys, is we have to use we can use the ASA or the angle side angle triangle congruence postulate, and after proving that the two triangles are congruent, we can then again use or go ahead and use CPCTC, or the corresponding parts of congruent triangles are congruent. So as with all proofs, let's start with a given. So number one, okay, so we have here parallelogram C8 caps with diagonals CP and AS. Okay, let's write that neatly. Okay, so we have here parallelogram caps with diagonals, what's that, CP and AS, was that right? Okay, so let's double check, guys. Okay, so that's CP and AS. Okay, so let's just write that neatly. And for the reason there, okay, so our reason here is we have here a given. Okay, given. Okay, for number 2, guys, we can write, okay, so for our second statement, if you look closely at the figure, if you're going to notice, we have here two pairs of parallel lines. We have CASP and CS and AP. If you look closely or consider CA and SP, so those are two parallel lines cut by a transversal. Okay, so it's cut here, okay, at this part by a transversal. So that's angle 1 and 4 that are alternate interior angles. Okay, they are alternate interior angles of this parallel line. So of the pairs of parallel lines. So we can write here, if we have alternate interior angles for number 2, that we have here angles. Okay, angles 1 and 4 are congruent. Okay, and they're congruent because alternate interior angles are congruent. Okay, so we can put that here, and we can also put that here. And for our third proof, okay, if you're also going to notice, we have here angles 2 and 3 are also congruent, because they also have they are also inside a parallel lines, or they are in between the two parallel lines, and there's a transversal that cut between them, and they are on the opposite side. So we can also say that for this proof we have alternate or for the reason for the statement number 3, we can say that the alternate interior angles are also congruent. Okay, so that's for statement number 3. And for statement number 4, if you notice, guys, that we have here a parallelogram, so that must mean their opposite sides must be congruent. So side CA must be congruent to SP, and side CS must be congruent to side AP. So let's write that. Okay, so but for this specific problem, since we're trying to prove CAL and SLP as the congruent parts, so let's use CA and SP. Okay, so for number 4, we have, okay, 4 sides or line segments CA and SP are congruent. And the reason for that is, so the opposite sides of a parallelogram are congruent. Okay. And therefore, after establishing that the angles, the alternate interior angles, are congruent, and we have the sides, the included sides here are congruent between the two angles, then therefore we can say on the 5th statement, okay, we can write here on the 5th statement. Okay, so number 5, okay, number 5, okay, we can write here that triangles, okay, triangles, what are the two triangles? We have our triangles CAL, CLA, and SLP. So we have here triangles CLA and SLP. Okay, SLP are congruent, so they're congruent triangles. So how did we say that? Okay, through the ASA, okay, the ASA triangle congruence postulate. Okay, so let's write that down here. Okay, so we have here ASA triangle congruence postulate. Okay, so there you go. Okay, and lastly, okay guys, lastly on our proof here, we can finally write, okay, for the sixth part, okay, what we want to prove is that CL, okay, let's go back here. CL is congruent, CL is congruent to LP and AL is congruent to LS. Okay, CL, and okay, let's write that neatly. Okay, so CL and LP are congruent, and okay, we also have AL and LS. Okay, and AL and LS are congruent. So those pairs of line segments or segments are congruent because of CPCTC, or congruent parts of congruent triangles are congruent because we've already established that the two triangles there are congruent. So that's our proof for the third property of a parallelogram. Diagonals of a parallelogram bisect each other, and using a two-column proof, we managed to prove this theorem. Okay, so for our fourth proof, we want to prove that a quadrilateral is a parallelogram if its opposite sides are congruent. So we're given here quadrilateral FLMD with line segments FL and TM, and they are congruent, and also FT and LM, they're also congruent. So those are given. Okay, so FL is congruent to TM and FT is congruent to LM. We want to prove that quadrilateral FLMT is a parallelogram. So how do we do that? Okay, so as with all proofs, we start with a given. Okay, so number one. Okay, so let's write our given. Okay, so continuing with our proof, we have here given a parallelogram FLMT. So as we can see here on a figure, we need to draw a line segment LT. So let's draw a line segment LT here. Okay, and let's label some angles. So this will be angle 1, angle 2, angle 3, and angle 4. So angle 1 is FLT, angle 2 is LTM, angle 3 is MLT, and angle 4 is FTL. So let's write that here for our second statement. Draw a diagonal, LT on the parallelogram. Okay, so that's the reason, or the proof for that is two distinct points determine a line. Okay, so for the third statement, we can say that LT, okay, so LT, okay, let's write that here. Okay, LT, okay, for first thing, LT is congruent to LP. Of course, the reason for that is, or the proof for that is the reflexive property of congruence. So after writing our third statement, we can state here on our fourth statement that triangles FLT and LTM are congruent. Okay, so they're congruent because of the SSS. Okay, SSS are the side triangle congruence postulate. Okay, because we've already proven that their opposite sides are congruent, and also the diagonal is congruent to itself, and therefore we have here two triangles that are congruent. And therefore on our fifth statement we can say that angles 1 and 2 are congruent. Okay, angles 1 and 2 are congruent, and angles 4 and 3 are congruent, not just because they are alternate interior angles, but also because of CPCTC, because we've already established that the two triangles are congruent to each other. Okay, and from statement number 5, we can say on statement number 6 that line segments FL and TM are parallel to each other. And also we have here line segments FT and LM are parallel to each other. Okay, so how did we say that? Because you've already seen here on number 5 the angles 1 and 2 and 3 and 4 are congruent and they're alternate interior angles. Therefore, our reason here is a parallelogram. So if a pair of parallel lines are cut by a transversal, then their alternate interior angles are congruent. Okay, so we can write that here. Okay, so we can put that proof over here. Okay, and lastly, we can now prove that quadrilateral FLMT is a parallelogram because it has a pair of parallel lines, okay, that are congruent to each other. Two opposite pairs of parallel lines that are congruent to each other, and when a transversal was cut between those two parallel lines, we formed two pairs of congruent alternate interior angles. So let's write that here. For number 7, quadrilateral FLMT is a parallelogram. And the reason for that is a definition of a parallelogram.